Implementing multiplayer into your game can be very daunting, but luckily, a turn-based card game is one of the easiest things to implement multiplayer into, and Godot makes it very easy for us. There's a couple of nodes you can use for Godot multiplayer, such as the multiplayer spawner and multiplayer synchronizer. These are great if you want to have multiple players in your 2D or 3D world and you want to replicate all their actions, but we don't need to replicate everything in our card game. For example, our opponent doesn't need to see when we're picking up cards in our hand and dragging them around. They only need to see when we place a card on the field. And for that reason, I'm going to use RPCs, or remote procedural calls, which will let us run code not just locally on our instance, but also instances or clients or peers that are connected to us. So for an example of how it'll work, for our player, we instantiate the player's field and the opponent's field, and then when another player plays a card, for example, we use an RPC to do that same action on our opponent's field. If you're interested in joining a community of game devs, I have my Discord linked in the description. And if you're interested in supporting me and getting access to my tutorial project files, the link to my Patreon will be in description as well. So you can see here in the main scene that we currently have all the opponent nodes and all the player nodes all together, but we want to separate these into their own scenes. So I'm going to come up here to scene, I'm going to make a new scene, and in here I'll set the root node to a node 2D, and I'll call that player field. And then I'll hit Ctrl S on my keyboard to save the scene, and I'll call this scene player field, and I'll save it into my scenes folder. And then, back in the main scene, I want to select all the things that are part of the player's field, so all the nodes. So I'm going to take card manager, card slots, player hand, deck, the end turn button, input manager, battle timer, player health, and player discard, and I'll right click and I'll copy all this stuff and I'll paste it into our player field scene. And now in here in the card slots node, you can see it also brought over the enemy card slots, so I'm going to make sure to select all of those and delete them. And now we want to do the same for all the opponent nodes, so we'll go up to scene, we'll create a new scene, select node 2D as our root node, we'll call it opponent field, we'll hit Ctrl S on the keyboard and we'll save this as opponent field. And then in main, we just need to bring over the card manager, the card slots, the opponent hand, opponent deck, opponent health, and opponent discard nodes. So we'll copy these and we'll bring it over to the opponent field scene and paste them in. And then make sure to select all the player card slots in here and delete them. Then we can go over to the main scene and delete all the nodes in here except the root node. Then I'm going to right click on the main node, I'll add child node and I'll add a button. And I'll rename this node to host button. And then I can copy and paste this node just to make a second one, and I'm going to call this second one join button. Then I'll just drag both of these buttons into view, and I'll set their positions, and I'll give them some text just to say host for the host button and join for the join button. With either of the buttons selected, if you go into this node tab, you can see we want to connect this pressed signal, but we have nowhere to connect it yet, so we're going to go up to the main, the root node, we'll right click, we'll attach a new script, and we'll call it multiplayer. And this script is where we're going to handle all the setup for our multiplayer functionality. We can delete the ready and process functions that the script starts with, we don't need them. We can start by creating a new variable in here called peer and setting it equal to enetMultiplayerPeer.new and open and close soft brackets. And I'll explain what this does. This is creating a new multiplayer object, and our object is called peer, whatever you called it here. And we're using the enet networking library, which is built into Godot. So you don't have to download any plugins or anything, this will just work. And now we need to set up our signal so we know when the host joins. So if we select our host button node and make sure we're in the node tab, not the inspector tab over here, we can double click on this pressed signal and then we can connect it to our multiplayer script on the main node here. And you can see it auto generates this function in here on host button pressed. And in here, the first thing we want to do is disable the host and join buttons so you can no longer see your press on them. So we'll call a new function called disable buttons, and then we'll create that function down here, and we can drag in a reference to our host and join buttons, and we'll set disabled equals true and visible equals false for both buttons. And now in the host button pressed function, after we've disabled the buttons, we're going to write peer.createServer, and in soft brackets we're going to put port. Now I'll explain what this line does in a minute, but first we're going to create port. We're going to come to the top and we're going to declare a new constant called port. And I'm going to set it equal to 123, but you can set this equal to any open port on your computer. And now the line peer.createServer port means we are setting our multiplayer object called peer to a server that is listening for communications on whatever port we're specifying, which here is 123. And the next thing we're going to do is set multiplayer.multiplayer_peer equal to our peer object. So on this line, multiplayer is a property that we can access pretty much anywhere in Godot, and multiplayer peer is a property of multiplayer where we can assign the object responsible for networking, so we're assigning it equal to our peer multiplayer object. And that's the multiplayer setup really done for the host, but now we need to instantiate the player field scene for them. So at the top here, I'm going to create a new variable called player field scene. And instead of setting this equal to the path of the field scene and loading that in, I'm just going to add an @export tag back at the start before this variable. And then after we declare the name, I'm going to put a colon and I'm going to say it's a packed scene. So we're declaring a variable of name player field scene, and we're telling it that the data type of the variable that it is a packed scene. And this export tag allows us to assign this value in the inspector. So now make sure this script is saved and that there's no errors. And then if we click on the main node, this root node that the multiplayer script is attached to, you can see this player scene property appears, and we can go into our file system and drag in our player field.tscn into this box that says empty. Back in our multiplayer script, now that we have a reference to player field scene, we can come to the bottom of onHost button pressed and instantiate it. We'll create a new variable called player scene and set it equal to player field scene.instantiate. And then we need to get that into the scene tree, so let's use the addChild function and pass in player scene. And that's all we need. So if we press play now, we can press host, and you can see we get an error, and that's just because it's instantiating the player scene, and we move some things into the opponent field, so some of these references are going to be broken. So in the battle manager, we can just comment out this line giving us the error, and we're also going to comment out anywhere else that we're referencing opponent health. Now if we give it a run and press host, you can see that it's instantiating our player scene, which has all our player stuff and none of the opponent stuff, which is working perfectly. And now that that's working, we want to add our join button signal. So we'll click that button and we'll head to the node tab. We'll double click on the pressed signal and we'll connect it to our multiplayer script, and it'll automatically generate that function for us. And I'm just going to move the disable buttons function down below the join pressed signal function just because it looks better, and then I'm going to call the disable buttons function in the onJoin button press function. So the host, when they press the host button, will have their peer multiplayer object set as a server, but for people who press the join button, we want to set their multiplayer object to a client that joins to the host's server. And to be able to connect, we need the host's server address. So we'll create a constant up here up at the top, const server address. And this is the IP address of the server that we want to connect to. And the way we're going to be testing this currently is we're going to have the host and the client running on the same machine. And because of that, we can just put localhost in quotes as the server address. Then we have to assign the object responsible for networking for the client that just joined. So we can copy this line up here where we did it for the host and we'll paste it in. And then we need to instantiate the player field scene for the new player that just joined. So we can copy these two lines and paste it down here. Now we can test this, and if we press the join button, you can see that we do get the player field instantiated, which works really well. But now we need some way to know if the client successfully connected to the server or not. And I can do that by coming up to the onHost button pressed function. And before we instantiate the player scene, I'm going to do multiplayer.peer_connected .connect, and in soft brackets onPeerConnected, which is the name of a new function. And then we'll come down here and make this new function onPeerConnected, and we'll just print player joined in here to test if it works. Now the code in this function will only run for the host, and it will run whenever a new client connects. Now to test this, we have to run the game twice, and on one instance of the game we want to press the host button, and then on the other we press the join button. So up here on the top left, if we press the debug tab and go to customize run instances, we can enable multiple instances and we can change that box to 2. And then if we give this a play, you'll see that 2 instances of the game play. And I'm going to make sure that I go into project settings and change it to be windowed instead of full screen so that I can move both around so you can see both. So now we'll play this again, and I'll just move them around so you can see both windows. And now we can press host on one and it works, but when we press join on the other, we get an error. And that's because onPeerConnected actually is going to take in the peer ID of whoever connected. So we have to make sure we take that in down there in the function. And now if we test it again, we'll press host on one instance and join on the other. And you'll see in the output, we get player joined is printed, which shows us that our multiplayer setup is working. The host can set up a server and the clients connect to it and everything is working. The next thing we want to do is set up the opponent field scene. So we'll come up to the top of the script and we'll copy and paste this line for the player field scene, and we'll export the opponent field scene. And then in the inspector, we'll drag our opponent field scene into that empty box and assign it. Then we'll copy these lines where we're instantiating the player scene and adding it as a child, and we'll paste it into the onJoin button press function at the bottom. And we'll change it to var opponent scene equals opponent field scene.instantiate, and then we'll add child opponent scene. If we run this now and we press host on one instance and join on the other, you can see we get the error cannot call method connect on a null value, and we can fix this by going into the opponent field scene, right clicking on the card manager and pressing detach script because we don't need this logic in the scene. And now if we run this and try it again, you can see that the opponent scene successfully instantiates for the client. And now we have to instantiate the opponent scene for the host, and we only want to instantiate it when a client connects, so we don't want to do it in the onHost button pressed. Instead, we can do it on the onPeerConnected signal. So if we copy and paste the opponent field instantiating and the add child lines into here and give this a run, we can then press host on one instance and join on the other. And when we do, the opponent field is instantiated correctly for both the host and the client that is connected, so they both have an opponent. Now you might be able to understand a bit more what I was talking about earlier in the video, where we're not actually playing opposite the opponent in the same scene or the same world. We're just giving the illusion of it, because both the client and the host have an opponent, and when the host does something like play a card, we'll do that same thing on the client's opponent field, and then if the client plays a card or does something, we'll replicate that for the host's opponent field, which gives the illusion of the two players being across from each other playing cards. If we come down here into our debugger, you might notice that we have some errors, and if we click on it, it'll take us into the battle manager and show us that the errors are in this ready function where it can't find these references, so we can just delete all of these from the ready function to get rid of those errors. The next thing to fix is that the client and the host both have the end turn button visible and they can interact with their cards immediately, so we want to disable all that. So in the card manager, we'll default inputs disabled to true instead of false. Then we'll select the end turn button node from the player field scene, and we'll set its disabled property to true or ticked, and its visibility to off or unticked. Then we'll go into the deck script, make sure it's the player deck, and in the ready function we'll just comment out all these lines for drawing the initial starting hand, because we don't want to do that yet. And then we'll go into the opponent field scene and open the opponent deck script, and we'll comment out the lines to draw in here too. And one more quick thing, we're going to replace our opponent deck array with whatever we have in our player deck array. Just make sure they're the same, and just make sure there's like 8 in there or something, because we want to test the drawing mechanic for the initial hand draw and afterwards, and test when we run out of cards as well. Now the next thing we want to do is we want to have somewhere to do our game setup. So I'm going to go to the player field scene, I'm going to click on the root player field node, I'm going to attach a new script, I'm going to call it GameSetUp, and I'll create it. We can delete the ready and process functions that the script starts with, and instead we'll create a new function called host setup, and in here we'll just pass for now. And we'll also create a function client setup, and in here we'll pass as well. Now back over in the multiplayer script, at the bottom of the onJoin button pressed function, we have a reference to player scene already, so we'll do player scene and we'll call client setup, and then we have to do it for the host, so at the bottom of onPeerConnected, which is when the opponent joins. And we don't have a player scene reference here, so we'll just get node player field since it is a child, and then we'll call the host setup function. Now in here, in the host setup function, I'm going to list out all the things we want to do in here. We want to set the player and opponent's health. We want to set the initial deck count and draw the initial deck hand as well. We want to enable the end turn button and make it visible since the host is going to be going first. And we also have to enable inputs for them in the input manager. So let's start by declaring our starting health constant up at the top of this script, and we'll set it equal to 10 or whatever you want. And then let's go into the deck script, and we're actually going to comment out this line where we're setting the deck count, and we want to comment out in the opponent deck the same line. And then in the battle manager here, we're setting the player health node text. We're going to get rid of that as well, and we'll comment out these 2 other lines here as well. We don't need them. And that way we're going to keep all our setup logic in the GameSetUp script. So I'll get rid of this pass here, and instead I'll get a reference to our player health node by dragging it in, and we want to set its text, and we'll set it equal to starting health, and we'll have to pass that through the string function to change it from an int to a string. And now we want to get a reference to the opponent's field, and there's a much cleaner way to do this, but I'm going to do .getParent, which is going to get that main node, and then I'm going to do .getNode opponent field since it's a child of main, and then we're going to get opponent health, and we'll set its text equal to, and then again string starting health. Now there's a much cleaner way of getting that opponent field reference that I recommend doing. I recommend doing it through a singleton or an auto load, it's called in Godot, which is much cleaner and more efficient, but I'm just doing it the lazy way. Then I'm going to drag in a reference to our battle manager, and I'm going to change our player health and our opponent health to equal starting health. Then I'm going to drag in a reference to the deck, and I'm going to call a new function called draw initial hand, which we'll have to make. And because we're going to be waiting inside this function, I'm going to add the keyword await before I call that function, so the code suspends there until that function's finished running. Then I'm going to drag in a reference to the end turn button, and I'm going to set .visible equals true, and then I'm going to duplicate that line and set .disabled equal to false. And then I'm going to drag in a reference to the input manager and set .inputs disabled equals false. And then I forgot to do this before we do the await draw initial hand from the deck line. I'm going to copy this reference to opponent field up here, and we're going to get a reference to opponent deck. And we're going to set a new variable there called deck size equal to 8, which obviously you can change to equal however many elements you have in your opponent deck array. And we'll also change the rich text label on the opponent's deck. We'll change the text there to also equal whatever number. Make sure the number is in string there though, because .text requires a string. And you can see how it would be much easier to get that reference now to opponent field if we put it in an auto load, but I'm lazy. And now for the client setup, we have much less to do. We're just going to copy all these lines above the await line and paste them into the client setup. And then we'll take the deck.draw initial hand, but we don't need the await there. And we'll put that into the client setup. Then before I forget, we're going to go into the opponent field, go to the deck script there, and we'll create that variable deck size. Then in the player's deck script, I'm going to create this draw initial hand function. And in here, we want to wait 1 second. And to do that, we need a timer. And we don't want to reuse the battle timer because that has its own specific function. So we're going to right click on the deck node and we'll add a new child node and we'll add a timer. And I'm going to call this deck timer. Then at the top of the deck script, I'll create a new variable deck timer. And in the ready function, I'll set deck timer equal to, and I'll drag in our reference to our deck timer node. Then I'm going to set deck timer.oneShot equals to true, so it doesn't loop. And I'll set deck timer.waittime equals 1.0. Then in the draw initial hand function, I'll say deck timer.start, and then we'll wait for that to time out. So we'll do await deck timer.timeout. And now you can see why we're using await when we're calling this draw initial hand function, because afterwards we're enabling our inputs, but we want all the cards to be drawn into your hand before we enable inputs. So the next thing to do is we can just copy this for loop up here where we're drawing however many times starting hand size is set to. Make sure you get these 2 lines as well. The draw card this turn equals false, and then after the for loop, the drawn card this turn equals true. So now whenever we call the draw card function, we want anyone connected, or another way of saying that is any peer. We want to draw a card on the peer's opponent field. And we can do that with an RPC, a remote procedural call. So I'm going to create a new function called draw here and for client's opponent. That's probably not a good name to call that function. You could maybe call it draw here and for peer's opponent is a bit better. And then instead of calling draw card, we'll draw here and for client's opponent. We'll call that function instead. And then also we want to call that function for whoever's connected to us or for our peers. So to do that, we can do RPC, soft brackets, and then in quotes, the name of the function. And then to make this draw here and for client's opponent function work with an RPC, we have to add this tag before it here. So we can do @RPC and in soft brackets and quotes, any peer. And now we're calling this function locally for us. And we're also calling this function on the peers instance. So now in here, instead of pass, we want to call draw card. But it depends if this function was called locally, then we want to draw a card. But if this function was called from a peer, then we want to draw a card on the opponent's field. So we'll do getParent, which since we're in the deck script, that'll get the opponent field node. Then we'll do .parent again to get the main node. Then .getNode, opponent field / opponent deck. And now we have a reference to the opponent's deck we can call draw card. And again, this would be a lot easier if we put that opponent field reference into an auto load. So then we don't have to do that getParent.getParent.getNode opponent field. So I recommend you do that. Now, we need some way to know if this function was called locally or if it was called from a peer. So what we can do is, before we do this for loop, let's get the player ID of whoever is drawing this initial hand. So we can do var player ID equals multiplayer, which is that property that we used before in the multiplayer script where you can just access from anywhere, and then we'll do .getUniqueID. Now, I haven't really shown you how IDs work, but for the host, their player ID or their multiplayer.getUniqueID is always going to be 1. And then when a client connects or a peer connects, they are given a unique ID which is generated when they join. That's kind of just like a jumble of numbers like 327, whatever it could be. So now if we pass this player ID into the draw here and for client's opponent function, and don't forget to pass it in the RPC as well, we can do that just by doing a comma here and then player ID. Then we'll take it in down here in the function. Now we can check if, and then we'll do multiplayer.getUniqueID to see which player is running this function currently. And we'll check if that equals whatever player ID we're passing in. And if it does, then we'll call draw card. And otherwise, if not, we'll do the getParent.getParent.getNode. We'll use that line to draw a card for the opponent. Now this works, this line, we can now check if this was called locally or not, because let's use host for example. If the host is the person that's drawing this hand, up there where it does var player ID equals multiplayer.getUniqueID, the player ID is going to be 1 there since it's the host. Then where we're calling this function and we're passing in 1, or the host's ID, then when this function is running for us, it'll check if 1 equals, and then we're passing in 1. So if 1 equals 1, we draw a card. So that's how that works. And if it's called on a peer and we're passing in 1 for the host, it'll check if, and then since this function will be running on the host's instance, it'll do multiplayer.getUniqueID, which it will be a jumble of numbers, whatever randomized peer ID they get. It'll check if that number equals 1, which it won't, then we'll draw a card for the opponent. And this is basically the same thing that we're going to do in a couple different places, wherever we have to replicate something. So for example, if a player places a card, we're going to use a RPC to replicate that for the opponent. And it's going to be the exact same setup as this function here. We can give this a test now to see if it worked. And you can see if I press host on one instance and join on the other, you see that our cards are drawn and the opponent cards are drawn on both instances. So it looked like it did work, which is really cool. You know your multiplayer is working and your replication is working. But now let's test the manually drawing the card from the deck by clicking on it. So we'll temporarily comment out this if drawn card this turn, return, a couple of lines here in the draw card function. And then if we test this again, you can see that we can click on the deck and draw cards, and that works fine for us, but it's not replicated for the opponent. So let's fix that. In the input manager, when we click on the deck, we're calling draw card. Let's change that to call a new function called deck clicked. Then we'll go into the player's deck script and we'll create that function. And this is going to be really easy. We just have to copy these 2 lines up here where we're calling draw here and for client's opponent locally, and we're doing the RPC as well. And then we also need to copy the line where we're getting the player ID to be able to pass it in. And that's it. Now it should replicate when you click on the deck to draw a card as well. One more thing, we're going to cut these commented lines, the if drawn card this turn, return, and we'll paste them into the top of deck clicked, because they aren't doing anything really in the draw card function. So we can put it up here instead. And we'll leave it commented out for a sec just to test this out. And if we give it a run, I'm going to position both of these instances so you can kind of see both. And if I click on the host's deck, you can see that a card is also drawn for the other player's opponent. So it's working perfectly. Now that we know that works, we can uncomment these 2 lines and deck clicked. One more change I'm going to do, which is going to make this look much better, is after we wait 1 second at the top of draw initial hand, I'm going to change the deck timer's wait time to 0.1, and then I'm going to copy these 2 lines to start and wait for the timer to time out, and I'll paste them at the bottom of the for loop, and that just makes it so there's going to be a small wait in between each card that's drawn. And if we test that, you can see that the cards are dealt out way nicer. And that's going to be it for this video. So we got our multiplayer set up and we have card drawing replicated. So we're more than halfway done, but this video is getting too long. So in the next video, we're going to do the replication for placing a card and also the replication for attacking. If you found the video helpful, please consider leaving a like and subscribe for more upcoming tutorials and devlogs.